you go. All right. So today we're going to do final exam question. It is important, my friends, that you do the questions. If I say do final review question, then you should do it. If you had the final review questions with you, then I'm sorry, you can ask me question 1 through 18. Now today also you can ask me questions about homework. All right, any homework. It can be from 1 through 7 because you're on 7. As a matter of fact, somebody emailed me a question yesterday or Monday about this question. So we're going to go over one of these questions because somebody already emailed it to me. You can email it to me, take a picture, email it, or you can send me a, what do you call that? A text message, right? Not text message, a message here. I have a chat on this program and you can send it to me. So I want you to do this question or that other question. All right. So you're supposed to be, right now should have completed or on the process of completing final exam questions from 1 through 18. Does anybody have any question? Do you want me to do any of these questions from 1 through 18?
13.
13. Okay, so let's go. Oops. All right, make sure that everybody has assigned the attendance. So let's go. I believe I have it here. So we're going to go to question number 13. And then we remember somebody emailed me a question. We'll go back to that one. 13. Okay, here. That's the question. And we're going to go to current page. All right. So let's go over this question. It says a bin contains, yes, 3 red and 4 green balls. Hold on a second. All right. Just want to make sure that I have it with me here because I worked all these problems before. Okay. Let's copy this 3 red and 4 green. So we have 3 reds, 1, 2, and 3. And we also have 4 green, 1, 2, 3, 4. 3 balls are chosen at random. So we're going to pick 3 times. We're going to pick a ball. Pick 1 times, 2nd time, and 3 times. 3 balls are chosen around with replacement. Replacement means that you take one and then you put one to replace it. If you take a red one, then you have to put back a red one so that you're always going to have 1, 2, 3, 4, 5, 6, 7. So you're always going to have 7 balls. That's good because, okay, 7 balls total. Okay. With replacement, let the random variable x be the number of green balls. So we are concentrating on the fact that we want green balls. Why? Because that's what the problem said. Let x be the random number of green balls chosen. So that's what we're concentrating. Now the first question says, why do you think this is a binomial distribution? Explain why it's a binomial random variable. Why? Anybody remembers?
Because it's independent.
There are 4. Remember, if you remember correctly, there are 4 types of conditions you have to have in order for you to have this a binomial distribution. So the first one is that you have a n value. What's your n value here?
The number of balls?
7.
No, in this case, the number of things you're going to do. They call it trials.
Trials.
How many times you're going to do something? It tells you. I put it here.
3.
3 times. Okay, well, 3 balls.
They said the
Yeah, right.
question is, I'm going to pick up a ball 3 times. So this N is the trials. Okay, so this is a good question because we begin to define this better. Okay, so we're going to do this 3 times. I always ask the question with binomial random variable problems. Ask how many times I'm going to do something, not how many objects you have. No, that's not the how many times I'm going to do something, or how many items I'm going to use. All right, so that's the first thing. The second thing is that you have to have 2 answers. Remember, that's why it's called binomial, because you only have 2 answers. Okay, do you have 2 choices here or 2 answers?
Yes.
Yes, you have something that is, sorry, the balls are either green or red. So you have 2 choices. So that's the other reason that this is a binomial. Now, some of you just said something which is very important, that the choices are independent. That is correct. The probabilities are independent from each other. Independent. What do you mean the probability is independent, right? Because if I take a red one, it doesn't affect what I'm going to take next. So each probability, by the way, each probability has, for example, for the red ones, is 3/7. Is that correct? And for the green ones is what?
4/7.
4/7. So this is going, the probabilities are independent. In other words, they're not going to affect each other. So, and the fourth thing is that the probabilities remain the same. Why is it that remain the same? Because they're being replaced. Remember, that's what the problem says, that they're being replaced. So if you take a red one out, then you have to put a red one back. So when you put your hand back into the bin, you still have 3/7 if you're talking about the red ones. If you're talking about the green ones, if you take a green one out, you have to put a green one back because the problem says that you have to replace them. So every time you put your hand in, the probabilities are always the same for the red and for the green ones. So these are the 4 things you have to check always before you do any kind of decision, whether this is a binomial probability or not. Questions with these 4 choices. Okay.
Ooh, yeah.
The next, oh, I shouldn't put A, B, C, D because it's the same question, sorry. All right, let me put a medium side. So this is all A, by the way. A has 4 different answers, individual answers. Okay, let's talk about B. It says construct a probability distribution table. Okay, I don't know if you remember the tables. Maybe I use a different color, where you have X first, and then you have P of X. I don't know if you remember that, right?
Yes.
X and P of X, and depending on what they out, find the mean expected value. So that means it's going to be the multiplication of this. So I'm going to write it so that I'm ready to answer C. Okay. Now X is they told you the number of green balls, So let's say you put your hand inside of this bin. Okay, here you're going to write the choices, not the probability, just the choices, the choices that you have. So if you put your hand inside, you have to list here all possibilities, all choices you have. So can you give me a number that I can put here? What would be the first number that I can put here? And then I'll explain what that number means, but maybe some of you already know.
0.
0. Why 0? Because it's the possibilities there that you don't pick any green balls, right? Remember, you only talking about green balls. Can you put your hand here and take a red ball?
Yes.
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 So that means that you have 0 green. you pick the red one, not the green one. You only making this table for green ones. Okay, what would be another possibility? You're doing this 3 times. 1 time, second time, 3 times, and that means that you pick up no red balls. So sorry, no green balls. You pick one, you got red. You pick the second, you got red. You pick the third one, you got red. Man, 3 times you pick red, so there's 0 greens. What could be another possibility?
One.
One means you pick one and you got red. Man, you pick another one, you pick green. You say, yeah, green. And you go the next one, you pick a red one. So you only have 1 green. Does that make sense to you?
Yes.
Okay, so maybe I write it here for those of you who are not, the possibilities. I shouldn't write it, but you know, it's good to know. I don't know if I'm gonna have, you can have, basically you can have red, red, red 3 times. So that means 0 greens. You can also have red. It doesn't matter when you pick the green. It could be at the beginning, could be at the end. It doesn't matter, right? So you only pick 1 green. What would be another choice? What would be another choice?
Well, two.
2, right? So that would look something like that: green, green, red. By the way, it could be in any order. I'm just typing one order. What would be another possibility?
Three.
3. So that means you were lucky and you pick all of them green, green, green. By the way, you can make a tree out of this because, you know, you can definitely move this around. You can have the green, you can have the green here. You can have the green at the beginning. So you can have the green in all different places. Okay. All right. So now we have to write the probability of that happens. This is a question that is a little bit complicated because you have to write the probability of getting 0 green. Now, because this is a binomial, they told you this is a binomial. By the way, in the final exam, there's not tricky questions. They tell you this is going to be binomial. So, and actually you proved that was going to be binomial. So how do you find the probability? Well, you can make a tree, remember? You can make a tree out of this, which is a possibility, which is going to be, if you make a tree out of that, it's going to be kind of long tree. You can pick 1 times, 2 times, 3 times. So the tree is going to be very big because how many choices do you have every time you pick something?
Yeah, sure.
How many choices do you have?
3.
No,
No, wait.
7 choices.
7.
That's the problem. You have 7 choices. You can have green, green, green. How many greens? 4 green, right?
Yes.
Green, green, and then you can have red, red, and red. And then another 7 choices from here. Another 7 choices from here, 7 choices from here, 7 choices from here, 7 choices, 7 choices, 7 choices. And then you write green, green, red, red, and then 7 choices from here and 7. And then you have your 3, right? 1, 2, 3. So you're going to have a lot of 7 to the power of 3, which is a lot. Remember, because you have to list every possibility. 7 to the power of 3 is 343. So your tree is going to be a humongous tree. What are some of the possibilities? You can have red, 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 because you only 3, right? 1, 2, and 3. You can also have green, green, green. You can have green, red, red, but you also can have green, and believe it or not, this is red 1 and this is red 2. So you can have red 2 and red 1. It looks the same, but in reality, there's 2 different choices. You can have, I don't know, green, green, red. So you're going to have 343 of these things. That's a lot. This is very similar to the problem that we spoke before. The only problem or the only difference here is that we have the possibility in this case that we can switch this around. You can put red 1, red 2, red 3, and then you can put another one would be red 3, red 1, and red 2. Why is this the case? Because in this particular case, you can pick any ball any way you want. In the one that we did before, the winning the games, they specifically wanted win, 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 lose, lose, lose. That was a specific way that they wanted. Here, it's not in a specific way. It can be any way, as long as you pick 3 balls. So how do you solve this problem? How do you fix it? Well, they gave you a little bit of a clue. They said this is a binomial probability problem. So if this is a binomial probability problem, you can use the formula. Remember the formula? NCX P to the power of X Q N minus X. I explained this formula in a video before. So if we can get all these values from the problem, then we can just replace it. Every time I do this, I can do it for 0, I can do it for 1, I can do it for 2, I can do it for 3. Because, see, and the problem that we had before, we never knew that it was a binomial probability problem. That's why it didn't work. But in this case, it does. So we need to find n, which is 3. Very, very good. Okay, what's the value of x? I gave it to you, it's here. No, it could be 0, it could be 1, it could be 2, it could be 3. That's the value of x. That's why x is here, right? So you have to repeat the formula for each one of them. We need the probability of P. Now, P in this case will be what we want. P is success. What is success in this case?
Getting a green ball.
Joe, 7.
407.
So 4/7 is correct. And Q is the opposite of this, which is 3/7, because remember, these two always have to be added up to 1. And 4/7 plus 3/7 is equal to 1, or 7/7. So I'm going to have to repeat this problem for each one of these. Okay. So the first one would be 3. Remember n. This is the formula NCX. So that would be 3C0. Which is this. This would be 3C1, 3C2, 3C3. Now, parentheses, we're going to put P. P is 4/7. 4/7, 4/7, 4/7, and 4/7. Now, to the power of x. Now, x is here. So this would be to the power of 0, to the power of 1, to the power of 2, to the power of 3. What am I doing here? I'm listing all of these 343 possibilities. That's basically what I'm doing. Now, Q is 3/7. And Q is 3 to the power n minus x. So I have to subtract these two numbers. 3 minus 0 is 3, sorry. 3. And here will be 3 minus 1. That's a 2. That's a 3, 7 always. 3, 7. And here will be 3 minus 2 is 1. And 3 minus 3 is 0. So this is a problem where I have an advantage. It makes it longer, but I have an advantage because this is a binomial. That's why they asked me to test this, because this is a binomial probability problem. Now I have to just work on this, each thing at a time. Now, I ask you, remember that I'm going to do one, and then I'm just going to copy the answers. Let me see if I can bring the calculator. on. By the way, almost any calculator can do this, or you can go online and pick up a probability, what do you call that? Even your, no, scientific calculator. Any scientific calculator can do this. All right, so menu, we're gonna go to 1, and we're gonna go 3C0. 3 is here. There's a button called options here. Options, and I don't have it here, so I'm gonna go to the next menu. And the menu is probability. This is the choice that I'm gonna pick, which is F3. And if you can see that there's the C value, which is F3 again. And I'm gonna put 3C0 multiply by, we have to put the multiplication on my calculator, 4/7, 4 divided by 7 to the power of 0, which is 1 anyway, times, open parentheses, 3 divided by 7 to the power of 3. Okay, and that will give me that value. Let me make sure that I copy that right. 3C0 times 4/7 to the power of 0 times 10 to the power 3. So this is a very small number, basically. Let's write it down anyway. It's 0.0787. I'm going to use 4 decimals. You can use more. The more you use, the better it is. So this is going to be 0.0787. If you repeat this, you're going to have here 0.3149. If you get this, it's going to give you 0.4198. And if you do this, it's going to be 0.1866. So let me go on the internet to see if we have a calculator that does this kind of things. Let's go first with scientific calculator. Let's see if it has one. I don't like it because this doesn't have the C value. So that's not going to be, let me see if I can put a binomial probability calculator. Wow, I don't even know if I have that binomial probability calculator. You see that? Wow, they have it. I don't even know how that looks. Let's pick the first one. Oh, look at this. Man. Probability of success on a single trial. Probability of success on a single trial. What was the probability of success for us?
4/7.
4/7. How many trials?
3.
3.
3. Okay. And the number of success, that would be X. Remember?
0,
X.
1, 2.
That would be, let's do 0 first. And then press enter. Let's see if we have, oh, okay. Number of success, I'm not sure what that's the X value, but then, oh, the probability must be between 0 and 1. Okay. This is not a nice calculator because I don't even know number of trials, number of success.
Graph success.
The probability of success would be 0 and 1. Then really, okay, so let's put 1. I don't know if that's.
No, but it's saying the probability of success.
It says 4/7 in a
Right.
single trial. Number of trials
And
and number
number.
of success. It says error. The probability of success must be between the probability of success. It must be single. It is. Oh, because maybe they don't have
The fraction.
fraction. So I have to put 4/7 basically. I have to write what is 4 divided by 7. Okay, so I got it. 0 point. So you still need a calculator to do this one. Let's see, 142, 4285 Okay, that's enough. So here I want 0 first. Let's see if that works. Okay, so look, it gave me the answer. 0.7871. That's what I wanted. If I want the probability to be 1, then that would be 0.31, which is what I wrote, 3149. You see? So I just have to put the decimal here, not the fraction. And you can do this problem, and it tells you there what is the probability for 1, what is the probability for 2. So you can use this calculator or any similar calculator to do any of your operation. If you keep doing that, you're going to get this. So you finish with B. Is everybody okay? Or
Yeah.
did I lose everybody? All right. I'm going to copy this table because I don't have space yet anymore. And I'm going to go to a new table. Now, what is the question that it continues? Find the mean of the expected value. The mean of the expected value is when you, actually, I put it here, but I won't have space. Oops, why is that so big? Okay, it's, ooh, why am I, oh, I know why. It's P x times P over x. So I'm going to take this and I'm going to multiply it times the probability. 0 times this number is 0. Anytime you multiply 0 times any number, it's going to give you 0. 1 times this is going to give you 0.3149. 2 times this, I'm going to cheat a little bit because I have the answer here, is going to be 0.8396. You're multiplying. Multiply. And if you multiply 3 times 0.1866, it's going to give you 0.5598. And then we're going to add these numbers because that's the expected value. And it's going to be 1.7143. Now, what does this mean? What does it mean?
Like that's the like
The experiment several times. That's like kind of the average number that we
yeah,
would.
like you're getting at least like 1/7, 1.7 balls.
Green balls.
3 balls, yeah, right.
Use the large numbers, use the law of large numbers to interpret the meaning of the expected value in X in the context of this problem. What does that mean? That if you keep doing this experiment or process, whatever you want to call it, if you keep doing this experiment, your average number of green balls will be 1.7, approximate 1.7. So that's the answer to that question. All right. Yeah, we did that one. It's a kind of long question, but basically that is the same thing. Now, why did I use this formula here? Because the problem said it is a binomial probability. Okay. All right. Do I have any other question? Are we awake? There is a question, like I said to you, from somebody sent me a question. Is it here? No, that's not the question. I think it's okay. I know somebody sent me a question. Let's see if we can find it. The person's gonna be upset with me. I know the person is online. I don't know if they want to say it.
Oh, Mister.
Yes.
Question 17.
From the final exam?
Yeah. The standard
Okay.
deviation.
Okay, question 17. All right, let's go back to this. I know somebody gave me another one. I'm so sorry. If you can, if the person is there and they want to share with a question with us, 17. All right, let's go back to the exam. 17. Please try to do your homework. Otherwise, this is not going to work. I'm sorry. 17. Remember, we have time. You can try to do the questions little by little, and you ask me a question. There will be days on the week that we will have questions. So let's go to another page. Okay. Oh, this is a good question that you asked me here. All right, question is the following. Okay, 17. A test consists of 10 true and false questions. To pass the test, a student must answer at least 8 questions correctly. Okay. If a student guesses on each question, what is the probability that the student will pass the test? So let's see what is that. Now they have 10 questions. So if you can imagine question 1, question 3, I'm gonna write this because I like to have visuals. 10 questions. And each question has, it can be either true or false, right? That's what it says there. True and false, 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 true and false. Very good. So these are the 10 questions and you have true and false. Now, the question says that to pass the test, you must answer at least 8 questions. You must answer at least 8 questions correctly. At least 8 questions correctly. So you have to have at least 8 of these questions correctly or more, right? You can have 8, you can have 9, or you can have 10. To pass the test, you could have 8, 9, or 10 correct questions. Does that make sense to you guys?
Yes.
Okay, so if you have less than 8, like 7, you fail. If you only answer 7 correctly, you fail. If you answer only 6, you fail. So you have to have 8, 9, or 10 because the word at least means that. If a student guesses on each question, what is the probability that the student will pass the test? So this question, even though, oh, I copied 18 too. If that question is not a question where they tell you this is a binomial probability, they don't tell you this. However, if you check the question that we just finished, this looks like a binomial probability. Let's see why this might be a binomial probability question. How many times you're going to do this exercise? Or
10.
this 10. Now, what is the value of X here?
The value is
Remember, like we did on the table, what are the choices you have for X?
10.
1 and 2.
8.
No, wait,
8,
what? 8.
9,
They say 8, 9,
or 10. In this case, it could be 8, 9, and 10. This is the same thing that we did before. So what is the probability of P? The
1 over 2.
1 over 2, and the probability of Q is 1 over 2.
2.
It's this here, 1 over 2, 1 over 2, 1 over 2. So in this case, the probability remains the same for every question. You still have 1 over 2, 1 over 2, 1 over 2. Each question, it doesn't change the possibility. Every time you answer one question, you still have true and false. So this is very similar to what we did before. Very, very similar to what we did before. So how do we answer this question? Well, we can
Use the formula.
use the formula, right? So we have to do the formula, same thing that we did before. This could be 8, 9, and 10. The next one would be the probability of doing that. So this would be 10C8, 10C9, and 10 C10. The probability here is 1/2 and 1/2, 1/2 and 1/2, 1/2 and 1/2. Here will be 8. Oops, I put this too close together. Here will be 9, and here will be 10, and here will be 10 minus 8 is 2, 10 minus 9 is 1, and 10 minus 9 is 0. And now we have to have, right? I don't know if you guys have a computer that you can do there or not. Maybe I can, no, I can't make this small. So let's do one using my calculator. Okay. Let's go to delete everything here because we don't want that. Okay. So it's 10 C8 times parentheses 0.5 close parenthesis to the power of a times parentheses 0.5 to the power of 2. Okay, so it gives you that much, 0.043. I'm going to use 4 decimals, so it's going to be 0.439. So it would be 0. Oops. I hate this. So it would be 0. What was it?
0439.
439.
No, 0439.
Sorry. I have terrible memory. 0439. So now we got to do it for the next one. And by the way, every time you do this, you don't have this calculator, you don't have to delete everything. I'm just going to change some of the values, which is going to be 9 here. So I'm going to put a 9 here. And I'm going to put, instead of a 2, I'm going to put a 1 there. And I'm going to get, this is going to be a very small number. I should put it in the calculator that way. If you don't mind, I'm going to save this. The way you save this in this calculator will be, you use this arrow, and I'm going to use a variable, x. And that's what it says. So it's going to be 9.7656 to the power of 10 to the power of 10 to the power minus 3. So I'm just going to write it, but I'm not going to 9.7656, 9.7656 to the power of 10 to the minus 3. Okay, and now we are going to do the last one. Okay, and that's gonna X erase. Oh, I shouldn't have erased everything. Oh, damn it. Okay, that would be 10. Hopefully, I still have X there. Let me see. Yeah, X still there. Okay, perfect. So it's 10 C10. Some of this you can actually do by. God. Why did I do that? Okay, option probability is 3. So we do 3, 10 C10 to the power of 0.5 to the power of 10 times 1. So I'm not gonna put, because 1/2 to the power of 0 is just 1. So I'm gonna get that other value, which is a very small value. It's almost the same as the other one, only this is to 4 decimals. So I'm going to save this because I don't want to copy that to another value. So it's going to be A. Okay. So I'm going to write the same thing here, 9.7656, 10 to the power of minus 4. And now what did they ask me to do? They want to know the probability. So I need to add these probabilities to be able to get that. I'm going to add the probabilities. Use 1, and I'm going to add the first number, which is 0.043. 0, 4, 3, 9 plus x. Remember, that's what I put the value, and a. That's what I put the other value. And it's going to give me 0.05 5. If I use 3 decimals, 4 decimals, it doesn't matter. in the answer for the back of the final review, the answer that they have 0.55, which is okay. They only use 3 decimals. So if you add all of this, it's going to be approximately, approximately 0.055. Okay. Now, here, this is the last question. B, find the mean and the standard deviation of the number of correct. All right, so the mean, this is question B. Remember, when you have binomial probability distribution, I told you that you have a formula for the mean. It's P times Q. You can also multiply this times this times that, this times that, and then you add that, and also that's going to give you the mean or the expected value. You can do this either way. In this case, I'm not going to multiply x times p to get an answer, and x times p to get an answer, x times the probability of p to get an answer, and then add it because the numbers are very big. I could do it, but I can have a trick, sorry. This is not the formula, sorry. The formula that I gave you, n times p. N times p, if you multiply this, it will be the same thing as multiply. That's a nice trick, right? So what is the n in this case? Is 10. And what is p? 1/2. So if you do this, you're gonna get a 5. So that was easy. I could do the same thing with this, but I think that's better. The standard deviation, I also gave you a formula. When you have binomial distribution, you have a formula which is a square root of n, p, and q. So n is 10, q is 1/2, and p is 1/2, and everything is going to be the square root of that number. So that would be the square root of 10 times, square root of, I made a mistake, 10 times 0.5 times 0.5, and that would give you 1.58. So this would give you 1.581. Okay, they're using 3 decimals. You can use 4 decimals if you want to. No big deal. Now, the last question is, what is the probability that in a random sample of, I'm reading the wrong one. It is unusual for a student to pass by guessing? Explain. It is unusual. Now, when they use the word unusual or usual or normal, it's because they're using the standard deviation and they're using the mean. And they're using the standard deviation to work with the mean. Now, the mean in this case is 5, right? That's 5. Now, if we use the standard deviation, and we use the standard deviation 1 to the left and 1 to the right, it would be 5 minus 1.58. So if you have 5 minus 1.581, that will give you here 3.419. Now, if you subtract another 1.581, it will give you 1.838. So this is 2 standard deviations to the left. And now you got to do 2 standard deviations to the right. So it's 5 plus 1.581. That will give you 6.581. And now another one, you have to add 1.581 because that's the standard deviation, which is 8.162. Now, why did I just do 2? Because I explained to you before that 2 standard deviations to the left and 2 standard deviations to the right is what's considered normal. Or another word for normal is usual, right? Oops. this is normal, but in this case, they're using the word usual and unusual. So this is usual. Now, anything outside of that, anything outside is not normal, not normal. And the other words that they're using is unusual. So unusual, unusual. Either word is okay. So the question is, can you pass this exam just by guessing?
Yes.
Yes, because 8 is inside of the normal. So 8 is passing. So that means that it is not unusual. So in other words, you don't, like if you really want to guess this, the possibility that you can pass this exam just by guessing is this. But again, you can also have one question right by guessing, or you can have 8, but it would not be considered abnormal, unusual. It will be considered usual. All right? Okay.
Yes.
I'm going to stop here because it's time to stop. I have another class. However, if you have more questions, bring them. I know that there was somebody who gave me a question. I'm so sorry. I thought I had it ready. I don't have it ready. Do me a favor. If that person remembers the question, oh, so bad. If that person remember the question, just please bring it to me. No, I don't know where I put the question. So sorry. Bring it to me next class and I'll do it for sure. All right, go slow. Please make sure you do homeworks. 1 all the way through 7. You're already responsible from 1 through 7. And also you're responsible for doing questions from the final review from 1 through 18. Next class, I will teach the next lesson, but then I want to stop. Like I'm teach a lesson and then I stop, and then I stop and I answer questions from the homework or from the final review. Okay?
Okay.
All right. Don't forget to sign the attendance, please. It's very important that we sign the attendance. Thank you so much, everybody.
Bye.
Okay, goodbye, Mr.
Bye.
Tomorrow.